Hello everyone. Do you know we all were born scientists? When we were kids, we always wondered how things work in nature, and a bunch of questions emerged from our minds. But with time, our curiosity gradually subsides because of fear, assumption, technology, and the environment where we are living in. Our knowledge of universe is just a tip of huge iceberg. Well, in this episode, I will introduce the fundamental nature of our universe so that I can ignite your curiosity about what we are fundamentally made up of. The universe is thought to consist of three types of substance: normal matter, dark matter, and dark energy. Only 5% of normal matter consists of the atoms that make up stars, planets, human beings, and every other visible object in the universe. About 27% is dark matter, and the remaining 68% is made of dark energy. According to chemistry, all 118 elements in our modern periodic table provide the idea that all normal matter is made of 118 different atoms. By combining each other in different ways, that leads to the formation of our universe. We have been taught that atoms are the smallest and fundamental particles of the matter in elementary school, and then when upgraded to secondary school, we came to know that there are even smaller particles than an atom. Those are electrons discovered by J.J. Thomson in 1897, proton by Rutherford in 1909, neutron by James Chadwick in 1932. In 1964, a physicist named Murray Gell-Mann, a Nobel Prize winner, discovered the most fundamental particle called quark. Quarks are widely recognized today as being among the elementary particles of which matter is composed. The key evidence of this existence came from a series of inelastic electron-nucleon scattering experiments conducted between 1967 and 1973 at the Sanford Linear Accelerator Center. There are six types of quark, known as flavors of quarks: up and down, charm and strange, top and bottom. Up and down quarks have the lowest masses of all the quarks. The heavier quarks rapidly change up and down quarks through a process of particle decay, that is, the transformation from higher mass state to a lower mass state. Quarks make up protons and neutrons, which in turn make up an atom's nucleus. Each proton and neutron contains three quarks. Proton, which is made up of two up quark and one down quark, whereas neutron, which is made up of two down quark and one up quark. Gluons are force-carrying particles which bind quarks together, forming hadrons such as protons and neutrons. Leptons are particles which do not take part in strong interaction and only interact with electromagnetic and weak forces. Well, there are six family members of lepton: electron, neutrino, electron, muon, neutrino, muon, tau, neutrino, tau. Leptons are said to be elementary particles, that is, they do not appear to be made up of small unit of matter. Leptons can either carry 1 unit of charge or be neutral. Electrons are the lightest lepton and have a mass of only that of a proton. A neutrino is a subatomic particle that is very similar to an electron, but has no electrical charge and a very small mass, which might even be zero. The neutrino is perhaps the best named particles in the standard model of particle physics. It is tiny, neutral, and weighs so little that no one has able to measure its mass. Neutrinos are the most abundant particles that have the mass in the universe. In 1970s, our best understanding of how these particles and the three of the forces are related to each other is encapsulated in the standard model of particle physics. The standard model of particle physics is the best theory to describe the most basic building blocks of the universe. It explains how particles called quarks, which make up protons and neutrons, and leptons, which make up electrons, that leads to the formation of all the non-matter. If you remember any of the physics you learned in school, it is possible you may remember that there are four fundamental forces of nature. They are gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. There is another elementary particle called bosons that occupy a special role in particle physics. They act either as force carriers, which give rise to force between the particles, or give rise to the phenomena of mass. Unifying gravity with the other forces has been so far unsuccessful because the Albert Einstein famous descriptions of gravity, the theory of general relativity, breaks down in the quantum realm of subatomic particles. When we dive deep down into subatomic world we called the quantum world, things are utterly different, and our understanding of microscopic world is beyond our perception. Since general relativity describes the large scale or cosmological structure of the universe, and on the other hand, the quantum theory describes microscopic or subatomic structures. The unification of these theories explain both the very big and the very small. This theory is often referred to as theory of everything.